Hello everyone, welcome back to my channel InfoSec Lab, and today we are going to explore some AWS Lambda service functions. Now this is a part of a series attacking and defending AWS services from TryHackMe's learning path. Hopefully after this room you learn more about AWS Lambda functions, what its components are, and then how to use several techniques to actually exploit misconfigure AWS Lambda functions. Alright, let's get started. Introduction to AWS Lambda. According to AWS, Lambda is a serverless, event-driven compute service that lets you run code for virtually any type of applications or backend service without provisioning or managing servers. While that's a mouthful of marketing jargon, what does it mean? Serverless is a concept that you, as the end user, do not need to build or deploy any infrastructure to run a Lambda function. AWS manages all of that for you. AWS claims you can simply write and upload code as a zip file. In reality, each Lambda function is that runs on its own container with multiple isolation layers between AWS customers, but all of that is abstracted away from the customer by AWS. Lambda supports a number of languages called runtime environments. The most popular ones are Node.js, Python, Java, and Go. Event-driven is what happens after you upload the code. All Lambda functions are triggered by an event. That event can be a manual invocation of the function or tied to other activities in the account, such as the console login, or a user writing an object to an S3 bucket. This event-driven nature allows you to execute or to create complex applications based on multiple AWS services. Because Lambda functions are event-driven, they have a few limitations. The most significant limitation is that Lambda functions can run for no longer than 15 minutes before they time out. AWS Lambda is one of the next frontiers of cloud-native applications, so it's important to know how they work, how to create them securely, and how they can be attacked. Additionally, many cloud security tools leverage Lambda to manage security events, so as a cloud security practitioner, you need to be able to build with AWS with Lambda. The learning objectives of this room is to understand the benefits and limitations of AWS Lambda service and Lambda functions, learn about the various components and settings for a Lambda function, understand the multiple ways a developer or operator can misconfigure a Lambda function to make it less secure. Okay, I'm ready to get started. Yes. This one, just configure your AWS account in TryHackMe, so skip this. The Lambda event model. AWS instantiates a new execution environment when a Lambda function is first invoked. This instantiation is called a cold start and is significant for applications where response time is critical. If multiple requests come in at once, AWS will scale up the number of execution environments. Only one invocation will run in an execution environment at any one time. However, after the invocation is completed, the execution environment will be reused for subsequent requests for a non-deterministic period, but typically between 45 minutes to an hour. After the Lambda execution environment is instantiated, the function handler is invoked. This is when the Lambda service calls a specific function or method in the Lambda code. The inputs of the invocations are called the events. Also passed to the handler is the context, which contains details such as the Lambda function name, logging information, the function timeout, and time remaining before the timeout occurs. Here's a basic Python function that simply prints out the environment variables inside the Lambda execution environment. Alright, let's take a look at that. We have import Bodo. Bodo is a very popular Python library used to interact with AWS services, and is widely used in SDK, which is software development kit. Okay. Logger. So this code executes when the execution environment is created and sets up how the Python logger will work. Okay. And then this code executes when the function is invoked. Okay. Lambda handler. The code outside the Lambda handler is executed when Lambda creates the execution environment. In this case, it's setting up by default Python logger module. Each time the Lambda function is invoked, the function named Lambda handler is called with the event provided by the caller and the context defined by the AWS Lambda service. This function then logs the event and each of the environment variables. When the Lambda function execution completes, the object returned is passed to the caller. Lambda functions can be invoked synchronously or asynchronously. In a synchronous invocation, the caller waits for the function to finish executing before returning. With an asynchronous invocation, the caller sends an event but doesn't wait for the execution to complete. It's incumbent. Not sure how to say that, but it's incumbent on the application designer to handle error conditions and the resulting output for these fire and forget invocations. You can develop Lambda functions in the Lambda console or via infrastructure as code like CloudFormation or Terraform. When you're developing in the console, you can create test event for your functions. So let's take a look at, we have Lambda right here. And then we have, try this one. And to create a test event, you click on the test tab right here. And then you're gonna be create a name of the event you test. So I would say my test. You can name it whatever you want, but as long as you understand what it does, should be fine. Click test, and it will execute the function. Here's the details of the executions. If it shows green, it means that the Lambda was the function was executed successfully. Okay, and here it gives you the whole summary of the executions. And depending on what you're looking for, you can actually go through the logs right here. Okay. Go to a Lambda page in your account, name track me Lambda function. Okay, generate hello world test event, invoke the Lambda, see what information is returned, what is the value of the context key memory limit in my, okay, where is it? Memory limit in megabyte 128. Now set the value of invoke function. You need that for the future task. Complete invoked function ARN. It's this one. Okay. Components of Lambda. AWS Lambda functions have many moving parts, and it's good to know what most of them are when defending, attacking, or just building with Lambda. You can find most of these settings and components in Lambda console, and we've created sample function for you to play with. Code. Lambda code is typically stored as a zip file in S3, but for smaller function, you can often pass the zip file as a part of an API call. Every code package must have a file name specified by the handler, and in that file, a function or method specified by the handler. The exact specifications for the handler are runtime dependent. Test events. You can configure the test events for writing and troubleshooting code in AWS console. Memory and timeout. You can specify the amount of memory allocated to a function, 128 MB to 10 GB. The Lambda service allocates CPU capacity to the execution environment based on the memory size. Additionally, you can specify the timeout of the function up to 900 seconds. AWS Lambda buildings uses two dimensions, the number of executions and the gigabyte seconds of executions. A Lambda function that uses 3 gigabytes of RAM and runs for 3 seconds will build at 9 gigabyte seconds. A 500 megabyte function that runs for 4 seconds will build at 2 gigabyte seconds. Runtimes. Every Lambda function has a selected runtime. Node.js and Python are the most popular runtimes, but Java, Ruby, .NET, and Go are also available. Customers can even create custom runtimes. You can find the complete list of runtimes at AWS websites, which is here. Environment. Role. The execution role is like IAM instant profile. It's a set of predefined permissions for the function. Uh, it's a set of predefined permissions. The function has permission to act on resources in AWS account in AWS least privilege fashion. You must explicitly define the ability to write logs to CloudWatch logs in the Lambda execution role. Environment variables. AWS Lambda allows configuring environment variables as part of the Lambda runtime. This allows developers to use the same code zip files across multiple environments, dev, test, or production. The same Lambda get function API call that gets the code will also grant you a copy of the environment variables and values. Because environment variables could contain sensitive information, AWS encrypts them using KMS, or which is known as Key Management Service. Invocation policy. In addition to the execution role, a Lambda function can have a resource-based policy that defines who or what can call the Lambda invoke function call on the function. When we discuss the resource policy in the IAM module, you invoke a function in the AWS account 01918 and so on. That was possible because the try.me tab function granted invoke function to all the accounts in the try.me organization. It is possible to have a public Lambda function that anyone could execute if they knew the account ID, region, and function name, the unique components of the ARN. Logging. The Lambda service will log any data driven by the function stdout to stdout output or std error messages to CloudWatch logs. The CloudWatch logs is AWS monitoring and observability service and consists of a service that can accept metrics and logs. CloudWatch also allows you to create alarms and dashboards about the metrics and logs. Each function will write its log to a log group called AWS Lambda and the function name. You cannot change the name of the log group, nor can you configure multiple Lambda functions to write to the same log group. VPC. By default, AWS Lambda functions are assigned public IP address from a dedicated pool of AWS own IP addresses. However, it is possible to have a function invoked inside your VPC with a private IP address. This is typically required if the Lambda function must communicate with internal resources like RDS database or a resource on the on-premise data center. When a function is created inside a VPC, a hyperplane ENI is created in each specified subnet that all Lambda execution environments share. Like all ENIs, these Lambda ENIs have security groups attached to them. While Lambda execution environments usually don't listen for incoming connections, you can use the egress rules of the security group to determine what resources the Lambda function can access. Concurrency and throttling. Since Lambda functions are event-driven, an extremely large number of events can potentially trigger a large number of execution. In order to capacity plan and avoid runaway Lambda builds, AWS implements concurrency limits on function executions. An AWS account will support 1,000 simultaneous Lambda executions in each region by default. If your application needs to scale beyond 1,000 concurrent connections, you can request a limit increase with AWS support. When the concurrency limit is reached, executions are throttled. Events are not lost, but instead queued for a later execution. Lambda developers can also set a throttling limit on a per function basis to not exceed the scaling capacity of resources the function relies on. Okay. EFS. Every Lambda execution environment has a 500 megabytes of scratch space in the temp folder directory. That is the only part of the execution environment file system that is writable by the function code. When the execution environment is terminated, the content of the temp folder are lost. For most use cases, that is fine. Lambda functions are intended to be stateless. A recent addition to Lambda is the ability to mount an elastic file system into the function. Amazon Elastic File System, or EFS, is AWS Managed Network File System service. It allows EC2 instances, containers, and Lambda functions to share a common file system. Lambda layers. Often, a developer needs to share a common set of code or library across a number of Lambda functions, rather than embedding the same set of code and libraries in multiple zip files across potentially hundreds or thousands of functions. AWS Lambda has a concept of Lambda layer. The layer is suspended and available to the runtime when the execution environment is created. Lambda layers have resource policies so that they can be shared across accounts. Files in the Lambda layer will appear in the Lambda file system under the OPT directory. Lambda function URLs. AWS recently introduced Lambda function URLs. These are dedicated HTTPS endpoint to your function, allowing it to be invoked all over the internet. The URLs are in the form of URL ID, .lambda URL, .regions.on.aws, where the URL ID is a unique identifier. AWS states, Lambda generates the URL ID portion of the endpoint based on a number of factors, including your AWS account ID. Because this process is deterministic, it may be possible for anyone to retrieve your account ID from the URL. Function URLs can be invoked with or without IAM authentication. If an IAM authentication is required, you must sign the request as part of the HTTP request. If no IAM authentication is required, any simple curl command from anyone will invoke the function. Okay. Using the AWS CLI, investigate this Lambda function in an account. Okay. Wait. I can't. Sorry. Yeah, for some reason I can't really scroll to the right. I could. Meh, whatever. The runtime right here, Python 3.7. Python 3.7. What are the first two sentences of the error message you received when the get function command tried to read the environment variables? Environment error code message. Lambda was unable to decrypt your environment variables because of the KMS access was denied. Please check your KMS permission. So these are the two first sentences. Using curl command, download the zip file referenced by the code location. Okay, right here. Open the file, enter the content of questions 3.txt. Copy link. Lambda. Curl and then this one. What? Got permission denied. Okay, let me try to reconfigure the account. Okay guys, I don't know what happened to the curl command line that I was using. that it gave me the error, and then it didn't download the Lambda function. So what I did instead was just copy the URL, paste it in the browser right here, and it will automatically download the zip file right here for you. Then next step, I'm just going to go to the folder where it was downloaded, copy that one. Stop. Was it in? No, it was in root. And then I think it was in Lambda function folder. I'll just paste it here. And I'll go back to the terminal to play around with that. What? Oh. And we've got the answer. Of all of the Lambda function in all accounts or in all regions, you have to download mine. Sorry, not to be sorry. Okay. Next, the handler function is missing from the zip file. What should the name be? It should be what's that? Handler? No. Handler. Every code package must have a file name specified by the handler, and in that file name, a function or method specified by the handler. The exact specifications for the handler is runtime dependent. Okay, what's that supposed to be? It's runtime dependent, so we know the runtime is Python, so I would say the last four is .py, but what will be the first one? Okay, let's run the command again. AWS EC2, no, not EC2, my bad. Lambda function, copy. Let's close this one. Close this one. Grow the handler function lambda head. Is it function? Okay, let's see what the head is. Recall that the handler file is defined by the handler as attribute of the function's configurations in the runtime. Okay, so in this case, it's the attribute configuration is the function. Okay. Moving on, Lambda misconfigurations and attack vectors. There are several ways Lambda can be misconfigured or attacked. The primary risk is by insecure code. Most Lambda functions execute based on an event that user generated. If the code doesn't validate user supply inputs properly, a Lambda function could be compromised. In addition to an additional risk is when the code writes sensitive data to SDL. This data will appear in the CloudWatch logs for the function and be visible to anyone with read access to the account. Another way that Lambda functions can be misconfigured is through overly permissive execution rules. Granting a function more permissions than required increase the blast radius of damage that an attacker can do with any code vulnerability discovered. Role permissions are available via the environment variables AWS Access Key ID, AWS Secret Key IDs, and AWS Session Token. If the code allows an external attacker to access these three environments variables, they would be able to use the power of the function to engage with potential privilege escalation or data exfiltration. While user-defined environment variables are KMS encrypted, they're typically easy to access from within the functions or via the API or AWS console. If environment variables are used to pass secrets to the function, those secrets are easy to exfiltrate from the account. How the Lambda function is invoked can be a security misconfiguration if the resource policy is misconfigured. While resource policies are usually used with the Lambda invoke function IAM_action, if you use Lambda asterisk instead, the principal would have the ability to upload new code. If the resource policy allows all AWS users, i.e. principals, asterisk, then you'll have major security issues. It's important to realize how Lambda concurrency works as an attacker and defender. As an attacker, you can use Lambda concurrency limits to engage in denial of service attack and potentially throttle Lambda functions to use to respond to security events. As a defender or author of the function responding to the security events, understanding how throttling and implementing some reserved concurrency can mitigate the potential damage from a Lambda denial of service event. Modifying a Lambda layer is a great way to inject malicious code into a large number of functions. Finally, when you call the Lambda get function API, part of the response is pre-signed URL to download the code zip file from the Lambda service S3 bucket. It is useful discovery tactic because developers often hardcode things in their applications where they shouldn't. In the next room, you get a chance to use many of these techniques to exfiltrate sensitive data using misconfigured Lambda functions. Using the command AWS Lambda get policy. Okay, let's do it. AWS Lambda get policy query policy output text function name and then paste the function name. Copy, paste. Lambda, correct. AWS LAMBDA, oh yeah. Yeah. Policy. AWS. Oh, there's a typo in the function name. Okay, let me try the command again. With the version range statement SID stack set. Effect allow principal action is invoke function resource try me lambda sample function with a condition string equals. Wait, let's hold on. What is the action for the most permissive statement? Lambda invoke function, that's the name of the action. Wait. Oh, over here. Under the condition section, string equal editor principal or principal organization ID. Okay. This one? Yep. in your code, there's a function named try.me lambda room. Inverse function invoke this function via the console. What is the secret connections key string? Invoke function. This one. Test. My test. Test it. Secret connection string. Lambda function secret connection string right here. Key. What file is this deployed by the AWS layer attached to this try.me lambda room inverse function? What was the lambda layer? Let's take a look at the code. Okay. Do we have anything in the group name, task, root, runtime, log stream, execution environment, lambda daemon function name, default AWS secret, runtime directory, initial type, region, access key, log level. Okay. Alright. Lambda layer files, flag.txt. Okay, now let's go to the code and try to modify the code. Okay, where is it? The Python file, lambda roots, lambda layer files. Here we go. Remember, we saw in the code right here when we ran the test, the output lambda layer files, and then it shows flag.txt right here. So in this Python code, it's going to be this section right here. So inside this folder OPT, there's a flag.txt. So flag.txt file. This one inside of ls, we use a cat command. Alright, once we change it, we can actually, no, we don't have to upload it. Save it. No. Okay, we have to deploy it. Okay, once we deploy the changes, then we can test it. Right here. Again, this is similar to what you did right here. Go to test and then you click test. It's the same thing, but sometimes it's a little bit inconvenient to go back and forth between these two tabs. So over here, the only winning move is not to play right here. That's the content of the flag. Alright, so the same right here, you can actually, in the code, you click deploy whenever you make changes to your lambda function, and then once the change has been saved, just click the test right here, and the output is going to be the same. So I prefer this way because it's a little bit more convenient for me to actually look at the code and look at the output every time I make changes to the code. And where is it? Track me. Okay. Index 5, the Python files, Lambda layer. The only winning move is not to play. Yep. So that's it. We finished exploring the basics of Lambda, AWS Lambda in AWS cloud environment. In the next room, we're going to leverage some techniques on how to exploit AWS misconfigure Lambda function to actually exploit the cloud environments and get access to the cloud, compromise the environments. All right. If you have any question, again, please feel free to reach out to me. And thank you for watching my video. I'll see you next time then. Bye.